Welcome to qnawire.
Okay, we have the following pretty wacky alkene, or as we'll see, triene. Take a second to sketch this one out. And what our best bet is going to be in terms of naming this is likely finding our longest carbon chain. It's fairly clear from this side of the molecule that this would have to be our starting point. So let's call that carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we could go in either direction here. That's rather arbitrary, but in either case, we get a 12 carbon chain as our longest possible carbon chain. We could potentially branch here, but that would be shorter, and branching here would also be shorter. So we found our longest carbon chain. This is going to be a dodeca something. We don't know yet the complete ending, but we do know that it will end in dodeca. Now we'll notice that our only functional groups are double bonds. We've got alkenes, but that we also have a double bond sort of sticking off of our longest chain. If you've not yet seen this, that is referred to as a methylene. Okay, so given that, we really have only the sort of three alkenes that are part of our chain, and then a methylene functional group sticking off, as well as a methyl group here, and a methyl group here. So the next thing we've got to decide is from what side of the chain will we start counting. Note that if we label this as carbon 1, then the first functional group we run into is carbon 3. That would be 3-methylene. Whereas if we start numbering from this side of the molecule, 1, 2, 3, etc., that the first functional group we run into is a methyl group at 2, and we'd like to have the lowest number for our first functional group. All right, so we're going to then go with the numbering scheme I've sketched in blue. That will be carbon 1, and carbon 12 will be all the way over here, which I'll now write in blue. Okay, that also means then that our methylene is on carbon 10, so we've established that we have somewhere 10-methylene. We also have 2,6-dimethyl. And as for our root chain, we know that it is an alkene. In fact, it is a 1,2,3 triene. And in particular, it is a 2,6,11 triene. So we have then for our ending dodeca dash 2, 3, 6, 2, 6, 11 triene. At this point, other than establishing E and Z isomerism, we have all of our component parts. So we're going to then look at this alkene here, which is our only double bond, which has unique substituents on either side, right? This double bond has methyl-methyl on one side, so that can't have EZ isomerism. This alkene has hydrogen on one side, so there's no easy isomerism, whereas this one has a very long chain and a methyl on one side, and the other side has once again a very long chain and a hydrogen on the other side. So if we count these very long chains as the highest priority substituents, then this alkene is Z. So we've established that that is Z. And as we only have a single stereocenter in this molecule, we don't need to number the Z. That can just go out in front because there's no ambiguity as to which that refers to. So at this point, we can start copying things down. We know that it's Z. Now what functional group should come first? We've got methylene versus dimethyl. This does not have an E at the end. And no letters coming after L comes before the E coming after L in terms of alphabetizing. That is, methyl comes before methylene. If you're wondering, we do not count the di when we're talking about alphabetization. So therefore, our methyl comes before methylene. That's all that is to say. So we have Z2, 6 dash dimethyl. Dash 10 methylene, 10 dash methylene. And that's our last functional group substituent. So no more dashes or anything. We just go straight into dodeca. 10 methylene dodeca. Dash 2, 6, 11. Triene.